Welcome to another edition of Sharp Shorts. In this one, we are going to discuss how to name and write the formula for acids and bases. Now, there are many types of acids and bases. We are going to stick to the original, the first definition, which was from Arrhenius. And later in the year, as we work specifically on an acid-base unit, then we will discuss plenty of others. Arrhenius bases are very simple. We won't spend much time on their naming. According to Arrhenius, bases are any compound that basically had the hydroxide polyatomic ion as its anion. So as you can see in the formula here for lithium hydroxide. So essentially they are ternary or polyatomic compounds, ionic compounds, and you just name them as such. So for example, this is lithium hydroxide, or here with magnesium hydroxide, of course I would just write the cation, magnesium, which is a +2, and then I would look up hydroxide, remembering that it is one of the only polyatomics with an ID ending, hydroxide and cyanide. It has a -1, that's right on my chart. And so again, the balance formula would just be Mg. I need parentheses, don't forget them, because I need more than one of this polyatomic. I need 2 hydroxides to neutralize my ionic charges. And there you go. So that's really it for bases. It's recognizing that when I see hydroxide, I'm talking a base, and there's no change to the name. Where the confusion comes in with folks is acids, and according to Arrhenius, acids are compounds where hydrogen is the cation. And so what happens then is that essentially you name it like a normal binary or ternary compound with hydrogen as the cation, and then after you've done that, then you look at these rules. So these are rules you should write down and get to know. In a sense, you're looking at a two-step process. You name it like you would a normal ionic compound, then you look at the ending of the anion, and that drives how you name the acid. So any compound that would have an IDE ending, that would be binary compounds for the most part, with very few exceptions. That acid would become hydroic with basically the stem of the anion name built in there. So that would be a hydro something ic acid. For the polyatomics that end in AT or IT, which is what polyatomics end in, then notice I don't use the prefix hydro. That's only used with ID endings. In that case, I just take the stem of my anion element and then I add either ic for AT endings or us for IT endings. Now, you can write those down if you didn't in class. Really, it's best just to work off of examples. And here we go. So here's what you can see in our formula is they're all acids because they all start with hydrogen cation. Whether they are binary, whether they are ternary, it doesn't matter. And you can see here we have us and ic and hydroic endings, which will determine what it is. Okay. So when I say it's kind of a two-step process, the normal binary ionic naming here, we would then say that we have hydrogen. Let me get this written quickly. Hydrogen is our cation, so we would write that out. And then, of course, nitrogen would be our anion, and we would say nitride because all binaries are a 2 elements end in IDE. Binary 2-element compounds, they always end in IDE. That's the key right there. Okay. According to my rules then, if with an ID ending, the acid name then starts as hydro, that's my prefix. Then I use basically the stem of the anion, which is nitric, and I add the IC suffix. So this becomes hydronitric. Oops, pardon my spelling and working with the pen here. Acid. Okay. So that would be a binary acid. Okay. Now, here again, for this, same thing. I'm going to name it like I would a normal polyatomic compound. So it's hydrogen. I'm having serious pen troubles today. And I looked that up on my polyatomic chart, and that is nitrate. Okay. Now, the key is the AT ending to that anion. And with ATE, all I do is I take this stem and I add ic. So this just becomes nitric. And that's what helps differentiate it from the acid we just did above, is that for AT endings I don't use the prefix, I just use the suffix. And that separates them, because otherwise they would both have the same name. So hydronitric acid, nitric acid, the difference is that one's binary and this one's ternary. Okay. Well, you look again and you say, hey, I've got another ternary compound here that's hydrogen, step one. And I recommend always writing it out until you get very proficient and immediately it's popping into your head what the name is before you change it to its acid name. So hydrogen. Now this one, when I look at this polyatomic ion on my chart, it tells me it's nitrite, IT ending. Now, the ITE endings say, again, just take the stem of the word and add us. So this becomes nitrous acid only because its normal ternary name ended in ITE, nitrous acid. Very similar to the two we have just done. But not the same in how the compounds that it is bound to, or the elements that it is bound to, and how they interact. Okay. So again, it's very important. How do I separate these all out? Is I first name them as I would a normal binary or ternary compound. I look at the anion ending, and I follow my acid rules. That for ID is hydroic, for AT is just ic, for IT is us. That will differentiate the different acids that I'm working with. Now, when I'm heading in to do the formulas, the nice thing is I know the cation. They're all acids, and according to Arrhenius, all acids start with hydrogen, and so I have the first ion because they're all hydrogen, which is a +1 charge. Okay? So whether it's phosphoric, hydrophosphoric, or phosphorus, they're all a +1. Now essentially I'm taking the rules that I had before and I'm going backwards. Phosphoric acid only has ic. When it only has ic as its name, and it does not have the hydro prefix, that means it was an AT ending. So in any AT ending is a polyatomic ion. So I go to my polyatomic chart, and I look for something like phosphorate, and I do see phosphate, which is PO4, a phosphorus and 4 oxygens, and the chart tells me it has a -3 charge. Okay. And then I balance, because it is on a compound, so I'm going to need 3 hydrogens and 1 phosphate group. There is my formula for phosphoric acid. Now, very close in name is hydrophosphoric, but hydroic would indicate an ID ending, which would be an element. So in this case then I would say, well, what is phosphor? That must be phosphorus, which it is. That's it, because phosphoride or phosphide, ID element, that would be phosphorus, which also has a -3 charge because it has 5 valence electrons. Okay, so in this case the formula is H3P. Very similar names, very similar elemental structure in hydrogen and phosphorus, but this does not have the oxygens associated with it because it's binary. It has 2 elements. And in the last one, the phosphorus, us means IT. Again, that should shoot me right to my polyatomic chart because that's the only place I find ITEs, and I look for something that's phosphorite and I see phosphite, close enough. It is very similar to phosphate, but it has 1 less oxygen, still has a -3 charge. And so that formula then, in balancing that ion compound out, is H3PO3. Okay. The acids take work. It takes a little bit to get used to that 2-step format, but when you do, they're very easy to work with because you know the cation already, and if you remember your IDE, AT, and IT endings, it should work out relatively smooth. Okay. So that concludes this episode, and there is probably a quiz for you to try just for practice on the Sophia site.